The German assault on Poland in 1939 shocked the world with its sheer speed and efficiency. In just 28 days, an entire nation was crushed beneath the weight of a military machine unlike any the modern world had ever seen. This was Blitzkrieg Lightning War, an entirely new philosophy of combat. Until that moment, military planners had assumed that armies would move as they had in the previous Great War, advancing in waves, seizing ground yard by yard. The German method, however, was different. It fused armor, air power, and radio communication into a single synchronized organism. Panzer divisions did not merely attack, they penetrated, bypassed, and disoriented. Coordination through real-time communication allowed units to maneuver independently yet act as one, collapsing enemy defenses with breathtaking precision. Europe trembled. France, once considered the strongest land power on the continent, fell in a mere 6 weeks. The world's democracies were paralyzed, struggling to comprehend what had just unfolded. And across the Atlantic, the United States, still recovering from the Great Depression and clinging to isolationism, watched in disbelief. American newspapers carried headlines describing unstoppable German steel. Politicians argued that oceans were the nation's best defense. But among military thinkers and engineers, there were those who saw something deeper and far more alarming. Blitzkrieg was not just about tanks, it was about coordination through technology. The Luftwaffe's fleets of dive bombers and fighters did not simply support ground troops. They communicated with them, receiving target coordinates in real time. Tank commanders could talk to each other and to higher headquarters by radio, a capability no other army in the world possessed in such completeness. Even the Soviets, despite their vast numbers, relied mostly on flags, flares, and couriers on motorcycles. To many Americans, this new form of warfare seemed almost supernatural. How could a nation with fewer tanks and planes achieve such overwhelming success? The answer lay in something invisible: the electromagnetic spectrum. Germany had learned to fight not only with metal and fire, but with information. In 1940, as Britain endured the Blitz, American industry was still unprepared for war. The U.S. Army ranked 18th in the world, smaller than Portugal's. Its tank corps possessed fewer than 400 outdated machines, most of them training prototypes. And yet, amid the bleak headlines, a quiet revolution was beginning in American laboratories and workshops. One of those laboratories belonged to Galvin Manufacturing Company, a modest Chicago firm better known for producing car radios under a new brand name: Motorola. Its engineers men like Daniel E. Noble, a visionary communications theorist, and Henryk W. Magnuski, a Polish-born radio engineer who had fled Nazi-occupied Europe, were experimenting with frequency modulation, or FM. At the time, FM was a curiosity, a cleaner but complex alternative to the amplitude modulation, AM, used by most radio systems. AM was simple but noisy, constantly disrupted by static, engines, and atmospheric interference. FM, by contrast, could deliver crystal-clear audio even under heavy electrical noise, a property that would soon prove priceless on the battlefield. Meanwhile, across the ocean, Hitler's regime seemed unstoppable. Norway, Denmark, Belgium, and France had fallen. Britain stood alone. When Luftwaffe chief Hermann Göring heard that the United States planned to build 50,000 aircraft a year, he burst out laughing. "The Americans will never achieve such nonsense," he declared. But in America, factories were stirring. Civilian industries Ford, Chrysler, General Motors were preparing for conversion to war production. Engineers who had once designed refrigerators, radios, and farm tractors began sketching blueprints for tanks, aircraft engines, and artillery. By 1941, the arsenal of democracy, as President Roosevelt called it, was no longer a slogan. It was an industrial awakening. Assembly lines that had built cars were now turning out bombers and jeeps. And in the heart of this transformation, Motorola's engineers were testing a new radio set that could link every tank in a formation into a single, cohesive network. Within 4 years, American factories would produce not the impossible 50,000 aircraft derided by Göring, but nearly 100,000 planes per year, a level of production that would rewrite the logic of warfare itself. By the time the United States entered the war in December 1941, its factories were already roaring. Detroit became a fortress of industry. Chicago, Pittsburgh, and Buffalo turned into living engines of steel and circuitry. American engineers no longer merely built machines, they built systems. In this new war, victory would not belong to the strongest tank or the fastest airplane, but to those who could coordinate them most effectively. That realization transformed the U.S. Army's approach to communication. While German panzer divisions still relied on a limited number of radios, usually one transmitter-equipped tank per platoon, the Americans were preparing to install a full transceiver in every single vehicle. To make that vision real, they needed a new kind of radio, compact, powerful, and immune to the roar of engines and the chaos of battle. That challenge fell to Galvin manufacturing company Motorola and to two remarkable men. Daniel E. Noble, a professor of electrical engineering from the University of Connecticut, and Henryk W. Magnuski, a young Polish engineer who had escaped occupied Europe with nothing but his technical notes and an unwavering determination to fight back with his craft. Noble had long believed that frequency modulation, FM, could revolutionize military communication. Unlike AM, which encoded information by varying the amplitude of a signal and thus suffered interference from every electrical spark, FM modulated the frequency itself, making it far more resistant to noise. The problem was that FM transmitters were bulky and delicate. They required precise crystal control and stable power conditions hard to guarantee inside a rumbling, vibrating tank. It was Magnuski who solved the impossible, designing a ruggedized circuit architecture that could survive the shocks of off-road movement and the heat of desert warfare. The result, completed in 1942, was the SCR-508, a radio system that would become the heartbeat of every Sherman tank and armored vehicle in the U.S. Army. It transformed a collection of machines into an intelligent, responsive network, what today we might call a distributed command system. The SCR-508 consisted of three main components. The BC-604 transmitter, producing 25 watts of output power, more than twice that of its German counterpart, the FU G5. A pair of BC-603 receivers, allowing simultaneous monitoring of two channels. The BC-606 interphone amplifier, which linked the entire crew via headsets and microphones. Operating across 20.0 to 27.9 MHz, the radio featured 10 crystal-controlled channels, each pre-tuned for rapid selection. With the flip of a switch, a tank commander could shift from platoon to company frequency or report directly to battalion command without retuning. For the first time, every tank could both transmit and receive. There were no longer dumb tanks that could only listen, as in German formations. Any Sherman could assume command if its leader was hit. Every crew was part of a dynamic web of communication. Field tests in late 1942 stunned observers. Engineers drove tanks across rough terrain, engines roaring, guns firing, and yet voices over the radio remained perfectly clear. Gone was the static, the distortion, the screech of interference. A tank commander could now say, "Target ridge line, left flank," and his entire platoon would pivot instantly, guns trained in unison. It was a revelation. That clarity came from the genius of FM. Where AM radios filled the air with hissing and crackling, FM signals remained pure. Even under heavy electromagnetic noise from engines, spark plugs, or artillery fire, the SCR-508 cut through with precision. The German FU G5, by contrast, used AM and operated at slightly higher frequencies, 27.80, 33.3 MHz. Its 10-watt transmitter struggled to maintain contact beyond 2 or 3 kilometers, especially when on the move. Communication often failed at the very moment it was most needed. The Americans had effectively conquered the invisible battlefield of sound waves, a domain the Germans had helped define, but now lagged behind in. The SCR-508 quickly became standard equipment across all U.S. armored divisions. By mid-1942, training grounds like Fort Knox were filled with the hum of FM transmitters. Crews learned not just to drive and shoot, but to talk, coordinate, and command in motion. The first real test came in November 1942 during Operation Torch, the Allied invasion of North Africa. As Sherman tanks of the U.S. 1st and 2nd Armored Divisions rolled ashore near Oran and Casablanca, each carried an SCR-508 humming softly inside its steel shell. Ahead of them waited General Erwin Rommel's Africa Corps, veterans of 2 years of desert warfare. The Germans were masters of maneuver and deception, but they had no idea that their enemy had just brought a new, unseen weapon to the battlefield. The baptism of American armor came in the blazing sands of Tunisia, under a merciless sun, and against one of the most formidable opponents of the war, Erwin Rommel's Africa Corps. When the U.S. 1st and 2nd Armored Divisions landed as part of Operation Torch in November 1942, they were green and largely untested. Their tanks, mostly M3 Lees and the newer M4 Shermans, were mechanically reliable but tactically inexperienced. Across the desert, the Germans waited with Panzer III and Panzer IV tanks, manned by veterans who had fought from Libya to Tobruk. But the Americans brought something invisible and unprecedented: a network. Every Sherman tank carried an SCR-508 FM radio, and every crew could transmit, receive, and coordinate in real time. What had been merely a technical innovation in a laboratory became, in the dust and chaos of Tunisia, a strategic weapon. Rommel's forces were accustomed to a strict hierarchy of communication. In a typical German armored platoon of 5 tanks, only one. The platoon leaders carried a few G5 transceiver capable of both sending and receiving. The others were fitted with simpler FUG-2 receivers, allowing them to listen but not to reply. Orders flowed in one direction. If a command tank was destroyed or lost, the rest of the unit was effectively mute. To Allied intelligence officers monitoring the first clashes near Spitla and Kasserine, the difference was startling. German platoons, once famous for their precision, began to falter whenever their commanders were hit. American units, on the other hand, continued to maneuver, regroup, and counterattack even after losing key leaders. It wasn't that the U.S. crews were braver or more experienced. They simply could still talk to each other. During the Battle of Kasserine Pass in February 1943, German tactical superiority was evident on the ground. Their panzers outgunned and outmaneuvered the Americans in the early stages. But amid the chaos of retreat and counterattack, U.S. armored elements retained an astonishing level of coordination. Tank crews from different battalions, sometimes from entirely separate divisions, communicated directly over shared frequencies. They warned each other of ambushes, directed artillery fire, and organized defensive lines without waiting for orders from higher command. To the Germans, it looked like improvisation guided by luck. In reality, it was communication turned into combat power. After-action reports from the Africa Corps reveal their surprise. Intercepted American transmissions were clear and strong, even at ranges far beyond what German AM radios could achieve. One German signals officer noted bitterly that American radio discipline was remarkably efficient and that their reception quality was far superior. The secret, of course, was frequency modulation. The Americans' FM networks cut through engine noise and atmospheric static that crippled German AM sets. Every burst of interference that might have deafened a few G5 was filtered out by the SCR-508's design. Where the German crews fought inside a storm of crackling noise, the Americans heard only clean, confident voices. Red 2, target at 11 o'clock range 400. Copy, adjusting fire. That calm efficiency translated directly into battlefield cohesion. Units that might otherwise have scattered or frozen under pressure instead moved like a single machine. Even in defeat, the Americans learned faster than their enemy realized. Each engagement taught them not just tactics, but how to think through the radio how to use instantaneous communication to turn confusion into coordination. When Rommel withdrew from Tunisia in May 1943, his forces had won many local victories, but had failed to achieve strategic dominance. By then, American radio coordination had evolved into a living doctrine. Crews drilled endlessly on call signs, brevity codes, and frequency discipline. Platoon leaders learned to command through tone, rhythm, and timing as much as through orders. The SCR-508 was no longer just a piece of equipment. It was the voice of the armored force. By the time the Shermans rolled onto the beaches of Sicily 2 months later, the United States Army had mastered something the Germans still didn't fully understand: that the true power of an army lies not in its weapons, but in the links between them. By the time American tanks rumbled through the narrow valleys of Italy in 1944, the U.S. Army had turned communication into a science. The SCR-508 network was now integrated not just in tanks, but in half-tracks, command jeeps, artillery observers, and even liaison aircraft. Every movement, from a platoon flank to a corps-level assault, pulsed through invisible threads of radio coordination. In contrast, the German army, still relying heavily on wired telephones and AM transmitters, was learning too late that its battlefield discipline had become rigidity. The Wehrmacht's communication system could issue flawless orders, but it couldn't adapt when the battlefield shifted faster than the chain of command could react. American units learned to exploit this. Tank commanders no longer waited for written instructions or map conferences. They responded in real time to what they saw and heard. A reconnaissance jeep spotting enemy armor could call in a fighter-bomber strike within minutes. A forward observer could direct artillery through a tank's radio network without even leaving cover. The line between infantry, armor, and air force blurred into a single, integrated combat web. In the hills of Cassino, in the streets of Rome, and later in the hedgerows of Normandy, the result was the same. Coordination became a weapon. When Operation Overlord began on June 6, 1944, the German command structure collapsed under the sheer speed of Allied coordination. Where German units waited hours for permission to reposition, American tank columns adjusted their routes every few minutes. Entire battalions moved as though guided by one mind, because, in a sense, they were. Every Sherman, Stuart, and half-track was a node in a living network of voices. Blue 6, advance to the orchard. Red 4, cover the left ridge. Roger, copy all, moving now. That real-time clarity gave U.S. armored divisions an advantage that no amount of German experience could offset. When the 2nd and 3rd Armored Divisions broke through at Saint-Lô and Coutances, their speed astonished both friend and foe. German commanders later described it as fighting ghosts, tanks that appeared and vanished before they could be countered. But the defining moment came at Ericourt, in the Lorraine region, in September 1944. Here, Colonel Bruce Clark's 4th Armored Division, barely a few dozen tanks, strong-faced over 200 German Panthers and Mark IVs from the newly arrived Panzer Brigades, 111 and 113. On paper, the Americans were hopelessly outmatched. The German tanks had thicker armor, heavier guns, and seasoned crews. Yet over the course of 10 days, the battle turned into a catastrophe for the Wehrmacht. Heavy fog covered the fields at dawn, and the Germans advanced blindly, expecting an easy victory. Clark's tanks, however, moved through the mist, guided by radio alone. Platoon leaders shared real-time reports. Enemy armor sighted at the Crossroads Range 800. Copy, we're shifting position to the left ridge. The SCR-508 network created a picture of the battlefield invisible to the eye but crystal clear through the ether. Even without visibility, American tankers coordinated ambushes, triangulated enemy movements, and shifted artillery with second-by-second precision. German units, by contrast, had virtually no tactical communication. Their command tanks, often destroyed early in the fighting, left sub-units leaderless. Smoke, terrain, and static rendered their AM signals useless. Many German crews advanced without even knowing where friendly forces were. In one exchange recorded by a U.S. signals officer, 3 American platoons encircled and destroyed a German column twice their size within 20 minutes. The after-action report concluded simply, "They could not talk. We could." When the fog lifted days later, the battlefield was littered with 86 German tanks, their hulks smoking in the autumn rain. The Americans had lost only 25. It was one of the most lopsided armored victories in modern history. Captured German officers were stunned. They had assumed they were fighting entire divisions, not a handful of agile units. The mystery, they realized, was not numbers, but connectivity. The Americans had transformed every tank into both a weapon and a transmitter. A thinking, talking machine capable of collective intelligence. This victory at Aricourt became the textbook example of what historians later called networked warfare. It wasn't born of superior firepower or heroism, but of communication and invisible edge forged in the laboratories of Fort Monmouth and proven in the mud of France. The German army, still fighting under centralized command, could no longer compete with an adversary that had learned to operate as a decentralized swarm. By late 1944, American tanks rolled forward not as individual machines, but as a chorus of voices, coordinated through the static-free rhythm of FM radio. By the autumn of 1944, the SCR-508 had become more than a radio. It was the nervous system of the American Army. Across Europe, the rhythm of battle pulsed through those clear FM frequencies. Orders, warnings, laughter, fear, all carried across the ether with astonishing clarity. It was communication turned into dominance. For the Germans, it was a mystery that deepened into despair. Their engineers had long recognized the technical advantages of FM transmission, but Hitler's armament priorities left no room for retooling production. Factories already strained by Allied bombing could barely maintain existing equipment, let alone develop an entirely new generation of radios. In 1944, German specialists from the Telefunken and Lorenz firms finally proposed FM sets modeled after captured American designs. A few experimental Fuji-16ZY variants were built, but none reached mass production. The Reich's industry was trapped, short on copper, crystals, and skilled labor, and suffocating under constant air raids. Meanwhile, American production lines rolled on untouched. The Signal Corps built and distributed more than 50,000 SCR-508 units that year alone. Every armored battalion, every command post, every maintenance truck was connected. What the Germans still treated as a tool, the Americans had turned into a doctrine, command by communication. At divisional headquarters, massive radio control boards allowed commanders to listen to multiple frequencies at once. Tank squadrons, artillery units, reconnaissance patrols, even air support. The battlefield became an orchestra, and the radio was the conductor's baton. After the victories in France, U.S. engineers refined the technology further. The SCR-508's cousin, the SCR-528, offered longer range and dual-channel operation for coordination between ground and air units. Pilots could now speak directly to tank commanders, guiding them to targets below. For the first time in military history, air and armor moved as one continuous force. A captured German after-action report from December 1944 described this with disbelief. Enemy tanks appear to cooperate with aircraft as if controlled by a single commander. We encounter combined attacks of armor and fighter bombers with timing too perfect to be coincidence. It wasn't coincidence. It was radio. When the Battle of the Bulge erupted that winter, the dense forests of the Ardennes swallowed sound and light, but not FM waves. American units that should have been isolated instead maintained constant communication, regrouping and counterattacking within hours. German officers, unable to coordinate through jammed AM signals, often had to rely on couriers, a method unchanged since World War I. This contrast between analog command and networked command defined the closing year of the war. As Allied forces crossed the Rhine in March 1945, the coordination achieved through the SCR-508 system reached its peak. Armored columns, infantry, artillery, engineers, and air cover all operated on interlinked frequencies. Commanders spoke a new language of mobility: net discipline, call priority, skip routing. The military was becoming digital in mindset long before it became digital in machinery. German prisoners repeatedly expressed astonishment at how swiftly American units adapted to chaos. One officer of the Panzer Lehr Division remarked, "Your soldiers fight as if every man hears the same thought." In a sense, they did. The network was the thought. Even before victory, the U.S. Army recognized that it had stumbled upon something far greater than a wartime advantage. The Signal Corps laboratories began developing post-war applications for automatic switching, envisioning radio networks that could reroute communication without manual tuning, the conceptual ancestor of modern packet-based systems. Historians later called the SCR-508 the first digital battlefield, not because it used bits or processors, but because it created a feedback loop between people, machines, and decisions. Information no longer crawled, it flowed. And wherever it flowed, the American war machine moved with it. Faster, clearer, unstoppable. When the guns finally fell silent in May 1945, the world's maps were redrawn. But so were its circuits. The lessons of the SCR-508 network did not fade with peace. They evolved. The engineers who had built the wartime radio systems became the architects of a new era. At Fort Monmouth, at Bell Laboratories, and in the newly formed MIT Radiation Laboratory, the veterans of the Signal Corps began to ask a new question. If voice and command could travel instantly across a battlefield, why not information across the entire world? The idea was no longer military fantasy. It was proven fact. In 1947, Bell engineers unveiled the transistor, a device that shrank what once required a vehicle into the palm of a hand. Radios that had weighed 30 kilograms could now fit into a pocket. The U.S. Army immediately envisioned a future where every soldier could carry a personal communication set, a direct descendant of the tank radio that had once defeated the Wehrmacht. By the 1950s, these ideas were already reshaping global defense strategy. The Army Signal Corps, now operating under the newly created Department of Defense, pushed for a unified communication grid, a system that could connect land, sea, and air forces through automatic switching and coded transmission. The earliest prototypes of this system, tested under the Autobahn and SAGE projects, were direct heirs of the FM coordination pioneered in the 1940s. In the air, new radios derived from the SCR-528 allowed pilots to link not just with ground control but with one another, creating the first airborne tactical networks. On the ground, armored divisions adopted lighter successors like the AN-VRC-8 series, which used improved frequency modulation and multiplexing, the embryonic form of modern digital routing. Even as the Cold War froze the world's politics, communication technology burned ahead. The same principle that had unified Sherman crews in the fog of Aracourt now connected radar outposts across the Arctic and missile silos deep in the American Midwest. By the early 1960s, this philosophy of resilience and redundancy, born from the chaos of tank warfare, inspired computer scientists at ARPA to design a system that could survive nuclear attack by rerouting data dynamically. They called it ARPANET. Half a century later, the rest of the world would call it the Internet. It is no exaggeration to say that the seeds of that revolution were sown in steel and static, in the cramped turrets of Sherman tanks and the meticulous notebooks of Signal Corps engineers. When the Global Positioning System, GPS, was developed decades later, its earliest field integration mirrored the SCR-508's purpose exactly: to give every unit an unbroken awareness of every other unit's position. Where 1940s commanders had listened to radio voices describing coordinates, their 1980s descendants watched digital icons move across electronic maps. The medium changed, but the dream was the same. Perfect situational awareness through perfect connection. The SCR-508's legacy was not in the machinery itself. Most of those metal boxes ended their days rusting in depots or museum displays, but in the philosophy it created. That communication is not a support function, but the core weapon of command. Every modern network, from battlefield data links to civilian cell towers, carries a trace of that realization. The tank crews of 1944 could not have imagined satellites orbiting above them, relaying encrypted data to soldiers half a world away. Yet the invisible threads that bind those satellites to their users were first woven in those chaotic years when engineers and soldiers learned to speak, literally, with one voice. In the end, the story of the SCR-508 is the story of modern warfare, and, in a broader sense, of modern civilization itself. A shift from silence to speech, from isolation to interconnection. From the roar of engines and gunfire, a new sound emerged, the steady, confident hum of communication. And it has never stopped since.